Hey everybody, Dr. A here, and in this video we're going to be providing some background information on average shear stress. So let's go ahead and get started. As we lead into average shear stress, I want to spend a minute or two recapping average normal stress and how average normal stress is different than average shear stress. So if you recall, average normal stress is a stress that is perpendicular to a member's cross-section. So if we have this 3D member here, average normal stress, for example, would have a force spread out over an area in 3D that is perpendicular to the cross-section. Okay, so something kind of like this, all right? And this would be, throughout that entire area here, all right? So this would be like an average normal stress in tension. If I were to draw this similar kind of element but in 2D form, then average normal stress would be spread out uniformly like this. And, this is showing it in particular in tension. Okay, compression would be pointing towards the member. So we know that. We've seen several videos on that. What about average shear stress? How is that different? Well, besides the word or the name being different, so shear stress, average shear stress is stress that is parallel or in the plane of the cross section. Okay, so instead of perpendicular or normal to the cross-section, like we have seen with average normal stress, we're looking at stress that is in the plane of the cross-section, all right? So, for example, if we have a similar member, like we just drew here, if I try to sketch this in 3D, okay, this is 3D. Shear stress would be in the plane of the cross section, just like this. Okay. And in 2D, if I were to draw this side view of this member in 2D, average shear stress would look something like this. Notice that it's parallel to the cross section or in the plane of the cross section. We call shear stress tau usually, the Greek letter tau, okay? Now, tau is going to be equal to a shear force divided by a cross-section area of some sort, okay? And so we abbreviate this as tau is V over A because V is typically the letter we use for shear force. Remember, shearing creates a slicing effect. So axial or normal forces tend to stretch or compress things, but shear forces tend to create a slicing through something, and that slicing effect will be parallel to the cross section, okay? Now, we have what is typically called direct or simple shear. Now, direct or simple shear occurs in elements with small cross sections. Now, what do we mean by small? We mean things like bolts, cotter pins, nails, welds, things with small cross sections. We are not really looking at columns or beams when we talk about direct or simple shear, okay? When we look at shear through bigger cross sections like columns or beams, that's not going to be simple shear. Typically we call that beam shear. And we're going to study that later in a different video or a different part of a mechanics of materials class. For now, we're going to stick with small cross sections where the average shear stress is simply shear force divided by area. Now, when we deal with those small cross sections, we typically deal with either what we call single shear or multiple shear, okay? So what does this mean? Well, single shear occurs when there is one shear plane, okay? So what would this look like? All right, so let's say we have two plates that we are attaching together by a bolt. All right, so let me draw these out for us. Okay, we have these two plates here. And then let's say we have this bolt that goes through these two plates. And you know, these plates are subject to forces. Let's call this P and P. And that is causing tension in these members here, these plates. But what are these forces doing to this bolt right here? Well, it's causing this bolt to want to slice in two, okay? It's creating a slicing effect, specifically at this interface that is connecting the two plates together, okay? So this interface right here that I'm coloring in red, that is our shear plane, okay? So this plane right here is experiencing shearing, all right? So if this bolt were to fail in shear, you would see that this bolt has like a slice through it right there at that interface, okay? So when there is one shear plane, like I drew in this figure, that's what we call single shear. Now, multiple shear is pretty much what it sounds like. This has to do with more than one shear plane at a connection, all right? So, for example, if you have two shear planes, what do you think we would call that? We'd call it double shear. What would happen if we had three shear planes? We would call that triple shear, so on and so forth. Now, in practice and practicality, you're probably not going to have more than three shear planes at a given connection. I mean, it's possible, but unlikely. Most of the time, we deal with either single or double shear, and sometimes triple shear, okay? So we very often see single shear and double shear scenarios. Occasionally we see triple shear scenarios. More than that, you probably won't see, okay? It just becomes impractical for that type of connection. So let's draw a figure of an example of double shear, okay? Let's say that we have three plates like this that are connected. All right, and let's say that, you know, there's a force here P, a force here P, and then for this to be in equilibrium, of course, this would have to be 2P. And let's say that we have this bolt that is passing through. So where are the two shear planes here? Well, here's one of them. It's the interface between the two plates that are touching each other. So this is one shear plane right here. And then here is the second shear plane, okay? So if I were to color these in red, here is the first shear plane, here's the second shear plane. So this is an example of double shear, okay? Because here that bolt is attempting to be sliced in two spots across two planes. So we call that double shear, all right? So that concludes our video introducing the concept of simple shear or average shear stress. If you found this video helpful, please hit like and subscribe and be on the lookout for more videos like this. Thanks for watching.